Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture, we are finally going to start doing some reinforcement learning. Instead of doing something ridiculously complicated this early in the course, we're actually going to take a step back and look at the tabular method again. Why might we want to do that? We want to show that it's not necessary to use the most complicated thing possible. In fact, by making some simple adjustments, you can make what you know already work pretty well. So this lecture is called CartPole with Bins, and I said earlier we're going to use the tabular method. This should give you a big hint about what we're about to do. We know that because the state space in CartPole consists of continuous variables, the state space is actually of infinite size. However, there are some states that are more likely than others. We know from reading the documentation that if we pass a certain angle or a certain position, the episode is going to end. So we know that while some states are technically possible, they are unreachable. We also know that attaining an infinite or very large velocity is highly unlikely, most likely also impossible. So what we can do instead is take a finite amount of four-dimensional space and consider that only. In this image, we're showing a 3D box because a 4D box isn't really a nice visualization, but the idea is the same. By cutting up the box into tinier boxes, we now have a discrete and finite state space. Therefore, we can use the tabular method once again. Now, this idea of cutting up the state space into boxes sounds simple, but there are some hidden details. For example, how do we choose the box size and the lower and upper limits? What if a state we observe is outside the box? For this first question, we can take sort of a naive approach and just try different numbers until it works. If you wanted to get more complex, you could play a few thousand episodes and plot histograms of each state variable to get a sense of how often you expect to see numbers in each range. For the second question, what do we do if we observe a state outside the box? Well, we can just extend the boxes on the outer edges to infinity. So that takes care of some of the details, but implementing it is going to be quite complex as well. I would encourage you to think about what this code is going to look like. There are going to be a number of steps. First, you need to convert the state into a bin, so that you can use it to index a dictionary or an array, which would be even better. This is not easy, so take some time to test out a few ideas. Another small detail I want to mention before we move on to the code is overwriting the default reward. The reward for CartPole is +1 for every time step. When you're doing Q-learning with bins, like I've described above, this reward structure actually doesn't work too well. What makes it work better is if you give the agent a large negative reward, like say -300, every time the episode ends. This incentivizes the agent to avoid reaching this point. Now you might wonder whether modifying the default rewards is a good idea or not. I've seen some debate about it online, but I generally feel that modifying the reward is okay. In the real world, if you're building an agent to solve a novel task, you would be the one defining the rewards anyway. It's up to the programmer to define an intelligent reward structure.